Good evening, students. So in the last class we stopped with the injection molding. Now today we are going to see the transfer molding. Okay, just a minute. Resin transfer molding. In the resin transfer molding, they will simply call it the RTM, resin transfer molding. Okay, dry reinforcement is pre-shaped and oriented into a skeleton of the actual part known as the perform, which is inserted into the matched die mold. Here you can see this is the requirement. So they are doing the outside tool, they are keeping the outside tool they are making. After they are taking the outside tool, they are trying to inject the resin. So after some curing time, you are getting the mold. After they are demolding, then they are using as a die mold. Okay, matched with die mold. The heat mold is closed and then liquid is injected. The part is cured in a mold. The mold is opened and the part is removed from the mold. This is the required part that is removed from the mold. Then resin mold transferring. The following steps are there using to make a close mold low pressure process. Okay, here initially they are closed mold low pressure process. A dry perform is placed in a matched metal die. A dry performance is matched. This is the mold structure. First initially perform manufacturing process, then lay up dropping. After the what they are doing there, they are keeping the dry. Then after that, what they are doing means next they are keeping the resin. Then they injecting and curing the process. After that, they demold and finally they are keeping the whatever the requirement of the part they are making. Okay, this is the initially this is the various performer of they will use as perform. Then after that their compression process, then injection. Similarly the same drawing will be this is the final cured part. Where vacuum pulls the low viscosity resin through a flow medium that helps the impregnated perform. Resin may also be forced by means of pump. Sometimes pumping also they will do. Here they will using the pumping process for injecting the resin. Then some catalyst were used to quick curing of resin. Then fiber is placed in between the molding process, closed molding process. After that they are applying some compression process. Okay, before applying compression process they are applying the resin. Then as well as at the same time catalyst they were then applying the compressor process. The remaining vacuum or some hairs will be the unwanted air, or sometimes even the excess resin will be went outside, will flow through the vent. Okay, next, transfer molding is a closed mold process in which a pre-weighted amount of polymer is preheated in the separate chamber and then forced into the preheated mold. We are forcing the mold filled with a reinforcing fiber. Here this is the place filled with the reinforced fiber. Then taking a shape in the mold cavity, impregnated the fibers and performing curing due to heat and pressure is applied. We are applying the heat as well as the pressure to the as a particular material, that is nothing but the fiber. Okay, the picture below illustrates the transfer molding process. This is the transfer molding process. Okay, the method uses a split mold and third plate equipped with a plunger mounted within a hydraulic press. Here you can see this a plunger with a hydraulic press which is used to apply the pressure. Okay, then the method combines the feature of both compression molding, hydraulic pressing, the same molding materials, and they will use the word as thermosets. Okay, and injection molding, ram plugger. Here you can see this is the thermosetting process. After this is the plunger they were used to apply this is the plunger used to apply the force for the thermosetting. Okay, what happened means when you are applying the force, what will it will be injected to the mold cavity via the spore. Okay, then Then the transfer molding cycle time is shorter than compression molding cycle but longer than injection molding. Here this is the important part. Transfer molding time is the very shorter than compression molding cycle but longer than the injection molding. So first injection molding is the easiest cycle. The time is shorter. Then transfer molding. After that we are getting after that only the compression molding. The method is capable to produce very large part, more complicated than compression molding, but not as complicated as the injection molding. So injection molding is the more complex part as compared to the other process, but compression molding is the easiest part, but we can develop the more complicated shape also. Transfer molding process involves in the following steps. We already see the same process only we are going to see here always. The mold cavity is filled with performing reinforcement fiber. Performing reinforcement with the fiber is already we are keeping for, and also we are making the part with help of the fiber only. Pre-weighted amount of polymer mixed with the additive and fillers, okay, charges. These placed into the transfer ports, okay. The charge may be in the form of powder, pellets, putty like a masses or preformed blanks. This charge is heated in the pot. Here we are applying the heat where the polymer softened. So here after that only the polymer will be softened. Due to that what happened, it will be spore or it will be go through the spore by applying the heat, okay. The plunger mounted on the top plate moves downward, pressing the polymer. When you are applying the pressing, okay, applying the pressing, okay, applying the weight or load, whatever the thing, polymer charge and forcing it to fill the mold cavity through the spur and impregnate the fiber. Impregnate the fiber is the important thing, because of how much amount of resin we required, we have to keep it that much only, okay. The mold equipped with a heating system provides curing cross-linking process of the polymer if thermosets is processed. That means if the thermosets, when you are using the thermosets, the cross-linking process will be taking place, okay. The mold is opened, okay. The part is removed from that entire by the means of the eject pin. Here this is the eject pin, here this is the eject pin, okay. Eject pin. By removing this eject pin we can get the part, okay. The thermosetting resin is molded. The mold may be open in hot state. Cured thermosets maintain their shapes and dimension even in hot state. So due to the using of thermosets, okay, we will get the as per shape at the hot conditions also. Thermoplastic molded, the mold and the molded parts are cooled before opening, okay. The scrap left of the part of the bottom, here this is the scrap will be available, okay. The scrap will be available in the spur, and the channel is removed in the spur, and the excess amount of thermoset resins and will be available in this part as well as the spur. So that will be removed after completing the process. Scrap of the thermostatic polymer is not recyclable. So thermostatic, we know that thermostatic polymers are not recyclable one. Once it is a scrap we can't use, but thermopolymers, thermoplastics we can reusable one. Then advantages of RTM is large complex shapes and curvatures can be made easily, okay. One of the biggest advantage compared to other process. High level of automation will be there, okay. Then layup is simpler than manual operation. Takes less time to produce. Fiber volume fraction is as high as 60% can be achieved. That is one of the important point, okay. Fiber volume, because only hand layup technique we can get the above 60%, but the remaining process, even the compression molding we can't get the, but here fiber volume fraction is, okay. Fiber volume fractions are as high as 60% can be achieved. Styrene emission can be reduced to minimum. Then cost effective high volume process for large scale processing. Then disadvantages are mold design is complex and requires mold filling analysis. So initially designing of mold is the thing will be there, that is the complex because of creating of the mold part. Then fiber reinforcement may wash and move during resin transfer. Resin transfer molding, and we already saw the advantages, but some more advantages are given. Low scale lab is enough, low tooling cost, but low volatility emission required design tolerability. But the some of the problems are control of resin flow is very important, because excess amount of resin will be flow due to the gravity. When you are heating, it will be converted as a liquid formation. So due to already liquid formation, but due to that heat, when you are heat, what happened means it try to reduce the viscosity. Due to that, more amount of resins will be flow inside the mold. Kinks of fibers, kinks of fibers, okay, will be happen critically in mold design. Mold design is the critical one, because the mold part is the final part. Okay, that is the requirement. So we have to design the mold design. So these are the examples of RTM products. Okay. Then next we are going to see the autoclave in the next video module.